name is Sean Ryan, a licensed PE and one of the sales engineers with Novatech. Today we are going to cover an example configuration using Novatech Configuration Director, commonly known as NCD. There are two portions to configuring the Orion devices. The first part is the offline portion, which utilizes NCD. This generally includes any of the points mapping to IEDs and upstream to a SCADA device, any of the math and logic, alarming, archiving, and any automation. The second aspect involves the online configuration while connected directly to the OrionLX itself. This includes typical things such as the network configuration, the users and user groups, security-related configurations, or any of the displays of previously built graphics. After installation, find the NCD3 shortcut located on your desktop or within the Start menu. Double-click and wait for the software to load. This is the diagram of the demo substation ABC that we are going to configure within NCD. In the middle is the Novatech OrionLX, where the substation RTU has an IP address of 10.10.10.10 with a DNP address of 10. It is connected via Ethernet to a Novatech OrionIO at 10.10.10.11 with a DNP address of 11. We also have a serially connected via RS-232 custom IED with a 9600 baud rate and a DNP address of 13. Finally, we have an Ethernet connected Schweitzer 351S relay at 10.10.10.12 utilizing the Schweitzer or SEL protocol. Finally, all of the data from these three IEDs are forwarded into the Novatech Orion real-time database, which converts all data into the DNP3 protocol to be sent on to the SCADA master located at 1234 or a DNP address of 4. To begin, under File, select New, then select the appropriate hardware, and in our case, the OrionLX. Select OK. Notice that after doing so, we now have the menu option of Configure, indicating that we have a file open and this is where most of the changes will take place. Also notice that the file name is Orion File 1 with an asterisk, or the fact that these three floppy disks in this area are colored, indicating that we have unsaved or pending changes. To save and name our file, under File, select Save As, then select Save Orion File 1 As. Under your My Documents folder or in your OneDrive folder, underneath the default NCD folder, here we can save the file, sub_ABC. Save. To configure our first Ethernet connected IED, or the Novatech OrionIO, underneath the Configure menu, browse to the network port, then select Configure New Port. What appears is a list of all of the available Ethernet-based protocols. In our case, we're interested in the DNP master protocol. Select this, then select OK. The window that pops up defaults to the port options. Here we can configure any of the parameters related to the port itself. The most common bits are reconfiguring the port name, or in this case, maybe we'll call it the OrionIO. Here we have the master address of 100. In this case, this is the DNP address of the OrionLX itself talking to the device. We're going to select 10 per what we had in our diagram. Underneath the IP options, we have the port as 20,000 or the default DNP port. And now we have the host or slave IP address. And again, based upon our diagram, we're going to put 10.10.10.11. The rest of the parameters are typically fine by default. Go ahead and click Accept. We also have the integrity poll groups. By default, the OrionLX is performing a Class 0 or an IntegriScan every 30 seconds, named as the default poll group. More poll groups can be added if desired, or the times can be changed, but we'll leave this as is. Now we're going to select Add New Device. And this is the device itself. Again, we could call this whatever we like, but in this case, I'm going to call this OrionIO 1. We only have one, but that's okay. The device address, this is also the DNP address of that device, and we're going to follow our schematic again and put a device address of 11. Again, most of the parameters below are fine by default. To save your changes, at the top, click Accept, followed by Yes to update the device. Notice the label has changed from device 1 to our configured device name of OrionIO 1. The strength and speed of Novatech's NCD software is the pick lists, or the list of pre-configured companies and manufacturers. Here on the left, we have a list of several different ones, such as Bytronics, with a list of devices on the right and several different meters created. We also have Cooper, several different reclosers, perhaps Schweitzer relays, with a list here of several different relay types available. But what we're interested in configuring is, again, the Novatech OrionIO. So we select Novatech, then select the device of OrionIO. Again, I'm going to click Accept and click Yes to update. When I now go to the menu of the configured inputs, we have a list of all of the different pre-configured or manufacturer default DNP points that are available within such devices. So for this instance, with the OrionIO, even though there could be several different variations, we have several different analog inputs, followed by several different binary inputs, and then binary output statuses and input counters. So for example, if I had an OrionIO with 8 analog inputs, I would simply select the first one. Then by holding the Shift key, I can select analog input 8, and I have a list of 8 points selected. My philosophy has always been that the points available are on the left, and whatever I want or care about, I send over to the right-hand side. So by doing so, I click the double brackets towards the right, and now I have 8 points configured, analog input 1 through 8, or DNP points 0 through 7. I can do the same for binary inputs. Let's say my OrionIO has a total of 16 binary inputs. I'm going to select number 1 as so, again holding the Shift key, select binary input 16, send them over to the right, and again I have 16 points configured from a DNP address of 0 to 15. I can do the same with outputs. In this list, I have all of the DNP possible pulses, latches, and outputs. So in this case, I'm going to pick the trip close output 1, 2, and 3 pairs, as well as the pulse output and a latch output. In this case, I select them, move them over to the right, and here I have DNP points 0, 1, and 2 as trip close pairs, 3 as my pulse, and 4 as my latch. Now that we are complete with the OrionIO configuration, we're going to move on and configure a generic serial device, essentially a custom device with a custom DNP map. So in this case, we can close this window, and now we can proceed back to configure, go through our configuration, and now find our serial ports list. Notice now that we already have these ports established, and these match to the physical output ports or serial ports that are on the back of the OrionLX. If we were configuring an OrionLXM, we would only have ports 1 through 8, and 9 through 16 would be grayed out since they aren't physically available. So in this case, we're going to select port 1. Again, as before, we're going to have a list of all of the available serial-based protocols instead of the Ethernet-based protocols. So there's a few more since we support some legacy devices and protocols. We're going to select DNP master, then select OK. And now we've got another window open. The port is going to be the only difference between the Ethernet and the serial based. Otherwise, the integrity polls and the device adding is going to mimic all of the exact same. So we're going to take a few shortcuts. However, again, within the port, we can change the port name. We're going to say this generic. And then again, we have the master address, which is going to be the DNP master address of the OrionLX itself, talking to the IED. Again, from our configuration, that's going to be 10. Down below, these will be all the serial parameters. We've indicated we're already going to use a baud rate of 9600, so in this case we're fine, but we can change any of these parameters if needed. At this point, we can click Accept. Again, integrity polls, same as before, but now we can click Add New Device. From here, because we're doing our own custom device, there's not a known manufacturer's default, so we're going to leave this as unknown and unknown, therefore making a custom template. Coming down here, I'm going to change the description, and I'm going to say this is device generic 1, and I'm going to give it my device address of 13. The rest of these parameters, again, are going to be the exact same as what we found in the Ethernet based. We're going to leave them as default. I click Accept, update the device, and now I come to Inputs. I'm going to maximize this window to make it a little easier to see the screens, but anyhow, you'll notice that there's no points over here. The reason being is because right now we're underneath all points. As soon as I select a specific point type, in this case if I wanted to create 3 binary points, I select the binary tab, and this is essentially filtering to only show binary based points. And by doing so, now we have a green plus icon that appears. When I click this, now I get the ability to create my own custom point names. So I can call this point 1, I can click the plus sign again, and now I can name this point 2. And you'll notice that it increments the point numbers automatically. As I click through and build these points, I can also right click, and this is a quick little shortcut, but I can say create a block of points from selected points. And in this case, I'm going to say create 10 points, and it's going to build a quick list like this. So this is a shortcut for building this just a little bit faster. So in this case, I've built a few points, and now that I don't want these, I'm going to simply send them over to the left and they'll disappear. Now I have 2 binary points. I can do the same for analogs. If I click the analog tab down below, I do the same thing. Click plus, I can say analog 1. I can click it again, I can say analog 2, and move on and so forth. Notice again that by default it's creating the scaling at 0 to 65,000. There's a few little shortcuts that I can do. If I click the 0, I can right click and there's predefined numbers for whether or not I'm connecting to a 12-bit, 16-bit, or 32-bit based device. So if I wanted to do a shortcut and change this to a 16-bit sign, I simply click that and do the same, and it's going to apply that for me quickly. The other thing that I can do is I can select multiple points, again by holding the shift key and selecting. This little icon here with the text box and the pencil is edit common attributes for selected points. I can click this, and by whatever changes I make and whatever I select here, or just by simply changing over here, it's going to do the same. I can do the same, put in defined numbers, or I can define them myself. Perhaps if for some reason I only wanted to do negative 20,000 to positive 20,000, now I can click apply, and it's going to apply that to all the points I have selected. I can further go to my outputs, change it to a binary, click plus, I can say output point 1. I've got that, and now I can change the binary type if I need to, from a trip close to a latch and a pulse. At this point, if I go back to all points, this is going to show my one binary trip close pair that I have for my outputs. And if I go to my inputs, I can go back to all points, and it's going to show me a list of all of the analog and points that I have. And this is how you would work towards creating your own custom DNP mapped devices. Now it's time to configure our Schweitzer 351S relay. I'm going to do so by going up to configure, and although it is an Ethernet based device per our diagram, I'm going to start by configuring it as a serial device. So I'm going to select serial ports and port 2. Through our available protocols, I'm going to search for the SEL or Schweitzer protocol, master, then press OK. I'm going to jump to our port options. Here we have any of the serial-based parameters to change, but the reason I wanted to start with a serial device is to show that, say, if I had a device in the field already that was changing from a serial to an Ethernet-based connection, I don't have to start from scratch. I can come up to my port options and simply do a move port. This will open up a dialog box allowing me to move disconfigured ports to any of the other serial-based ports, or per here, I can configure a new network port. I'm going to select this, then press OK. Now my port options have changed. It's no longer a serial device, but now it's an Ethernet-based device. I'm going to change this to our diagram assigned IP address of 10.10.10.12, and then I'm going to click Accept. Now I can return to my device. Per my pick list, I'm going to find my Schweitzer 351S relay. I'm going to click the generic one. There are firmware specific points, but this will suffice for our demo. Now doing this, I click Accept. Do I want to update? Yes. And now it is pre-populated otter and tail for my level 1 and level 2 Schweitzer passwords, and I can give this a device. I'm going to call this feeder 1. Click Accept. Update? Yes. And now I can go to my Inputs tab. Here we have a list of all of the different Schweitzer points available from the relay. But for demonstration purposes, underneath all points, I'm going to filter this to my analogs. And I'm going to grab, I can either hold shift or control in this case, but I'm going to grab the A, B, C, and neutral phase currents, as well as the A, B, and C phase voltages. And then I'm going to send them over to the right. I can come over to my discretes, and let's monitor a trip. And then on my outputs, I can grab a breaker control, and maybe there's some reclosing or something assigned to remote bits 1 and 2. Now that our first feeder is fully configured, without a doubt there's always more than one feeder at a substation, but I'd hate to configure an entire second feeder from scratch. So in this case, we can select our first feeder, and now in order to quickly duplicate this, we can copy our port. Copy to another network port, select OK. And again, it's Schweitzer master. We change our IP address, possibly to say a pseudo feeder at IP address 20, click Accept, change our name to feeder 2, click accept. And now when I come to my inputs and my outputs, the same configuration from before is already complete and pre-populated. To move on to my next and possible third feeder, again, copy port to another network port, change it as such, accept, come to my device, name it feeder 3, and you can move on and so forth. Now again, because in our example we didn't have such ports, now we can easily remove them by clicking delete port, and again delete this one as well. Now we're back to just our first feeder. Now that we've configured all of our IEDs, it's time to create our DNP slave port that will talk upstream to a SCADA or EMS system. So this time I'm going to close this port, and I'm going to go to Configure, find our Network menu, and Configure New Port. This time I'm going to select the DNP3 slave protocol rather than the master and press OK. At this point, now we can, similarly to before, we can give it a port name, or in this case I'm going to call this EMS_SCADA. Going down, here we have the reservations. This is not needed, but if you want to limit the connections to only a certain IP address and DNP address, we can do so. So in this case, since we had done an IP address in our diagram of 1.2.3.4, I can go ahead and do that. The master address would be 4, and the slave address would be our OrionLX of 10. Not needed, so I'm going to remove that, but that's just for an example. At this point, I can go ahead and click accept. And now I'm going to say add new RTU. And this is going to be the OrionLX configuration. Address is going to be 10, following our diagram of the OrionLX itself. Coming down, we can change the time zone of the timestamping if needed. And we can also apply timestamping to any of the Class 1 and Class 2 summaries. Coming down, we have unsolicited responses. So if unsolicited responses are desired, we can enable them just as so, and then finally click accept to save, then click yes. When it comes time for configuring the points list, we're going to start underneath inputs, and I'm going to maximize this window for clarity. Up above we have a filter port. Now I can filter by ports in general, so I can filter to just my generic IED that I configured on serial port 1, or we can filter down to some of the specific Ethernet devices, so my OrionIO or the SEL master. As I come back to the OrionIO, I want to point out that in the background, NCD has created these 3 points by himself, in the past referred to as DNP pseudo points, but we have a counter of polls, responses, and a binary indication of communication failure. Again, these were created by NCD itself. Furthermore, I can go up to this filter, and I can put in my own text. So if I was interested in just a point with a name with analog in the text, I can do so. I can type anything in here and it's going to filter that down for me. To begin adding points, again, what's available is on the left, and what I want or care about, I send over to the right. I'm going to filter down to just show binary points to begin with. But again, holding Control or Shift, I can select the points I want. I'm going arbitrarily here, but I want the first 2 points from my generic IED. I want the first 8 binary inputs from OrionIO, and let's also go ahead and grab something from the trip monitor from my feeder. I'm going to select those, then send them over to the right. If needed, I can also create spares or spacers just by clicking the green button, similar to how we did in the IED creation. Again, if I want to get rid of those, select both holding Shift, send them back to the left, and I can remove points. In similar fashion, I can switch over to the analog points and do just the same. I'm going to grab the first 2 analogs from my generic IED. I'm going to grab the first 4 from my OrionIO, and then I'm also interested in all of the measurement values from my feeder. Select them, send them over to the right, and good to go. Coming back to the binaries to make modifications to the points themselves, if I need to invert any of the points, I can change it from a normally open point over to normally closed. And this is going to change any of the 0s to 1s and the 1s to 0s and vice versa going up to SCADA. Quick way to invert the points. On my analogs, the first bit to consider changing are the deadbands. Now by default, everything is set to 80, but I can select multiples like so. And again, going up to this edit common attributes for selected points, I can click this and I can change my deadband to a value of 5. And by changing the number, it automatically selected that checkbox for me. And again, in similar fashion, I can change any of my scaling outbound to EMS2. I can use the shortcuts, change it to a 16-bit signed and a 16-bit signed, and I'm good to go. Similarly, if I wanted to divide a value by 10 going to SCADA, I could add a decimal in this place. Otherwise, if I wanted to multiply by 10, I could remove the decimal and simply add zeros after these. And then click apply. But I feel like dividing, so I'm going to go ahead and do that in this case. And then click apply. And you'll notice for those points that I had selected and used for edit common attributes, my deadbands and my scaling has all changed as shown. If I go back to my outputs tab, again, I have binary outputs here. I can select outputs from different IEDs. Again, choosing arbitrarily, but the ones I care for, I send them over to the right, and now I have DNP points 0 through 5 for these outputs. Again, coming back to inputs, I have 0 through 12 for my analogs. For my binaries, I have 0 through 10, and I can change these as needed. If I needed to have a jump, I could change this to DNP point 15, and so on, but it automatically increments the points as you go along through the creation. Now that we have a points list, I can return back to all points for a quick summary of all my inputs. I could do the same for the outputs, returning back to all points, but again, they're all binaries. But at this point, we now have a valid configuration. The last thing to do is either do File, Save As, or I can click these three little floppy disks as before. When I click this, it's going to save the configuration, and now it's time to browse to that .ncd file and time to finally load it onto our OrionLX.